Welcome, everyone. This is Developing Automation with a Limited Workforce. Our presenters today are Bob Van Single and Rodney Leversey.
Morning, guys.
My name is Jason Dornbos. I am sort of the moderator guy. I'll try not to do too much talking. Because the other two guys, they're the ones that know the stuff all about automation. So real quick, I just want to make sure everybody understands there's a chat. You can go there, type messages to us, type questions. Please do that throughout. If there's something that you're not sure of or wasn't explained well or whatever, just say it there. We don't want to leave anyone behind. So if you are wondering, please type and we will do our best to answer those as we go along. And if you are curious, there's actually another webinar next week at the same time. It's about laser, and we'll talk a little bit more about that at the end, but you can sign up for that on the on Excel's website. So I think without further ado, we should get started.
Sounds good.
Okay.
Let's go. All right.
Bob, take it away.
All right. As Jason mentioned, my name is Bob Van Single, and Rodney and myself, we both work in what's called the Manufacturing Solutions Center. Basically, what we do in there is we take the customer's request and we come up with concepts and then write up proposals that pertain to like cycle time or budgets or whatever it is the criteria is. And that's what we do for our day-to-day job. But for today, we want to talk about the automation with a limited workforce. So the first thing we want to focus on today is just talking about why do companies automate. Now, there are several different reasons why a company would automate, and we're just going to kind of go through a few of these, and then we'll kind of dive into one in particular. So there are many benefits to adding automation to your process. What? Not working.
No, just click on the area. Oh, there you go.
One of those benefits is increased productivity. The automated system can perform tasks more efficiently than a manual operation. So obviously your productivity would come up. Better quality. Automation can ensure, and it's very repeatable and efficient. So your quality also improves. Safety. Automation can replace any of those higher risk areas where you kind of have people doing something that maybe could cause harm in some way to them, and it kind of takes that away. So it definitely helps with safety. Another thing is kind of an obvious thing, I think, is it reduced cycle time. And then that's kind of self-explanatory. And then the final one here is it reduces or eliminates manual tasks, which allows for the maximizing of labor. And that's kind of what we want to focus on today. Most companies today have been impacted by the labor shortage that seems to be out there. I know there's several companies looking for people, and it seems like you can never fill those positions. So the one option you have in filling those positions is to start looking at automation to try to minimize the amount of labor that is needed.
No, labor shortage right now?
Yeah, right. So the most effective way, obviously, to maximize your labor is to add some type of automation into your process. Automation levels can be defined in several different ways, but for today, we're going to define them into these three categories. The first category is what we're going to call low-hanging fruit, which is minimal. It requires minimal implementation. It's a lower cost. We're saying, it's roughly less than $50K to implement. And there's slight reduction in labor time, so cycle time. And then we'll go into mid-level automation, which has a higher implementation cost, but it does remove a significant amount of manual operations. And it also can cause, or has a reduction in overall labor. And then the final one is the high level of automation. In here, this is where we would implement several of the mid-levels, but then also we would start with the feeding of the line being automated as well. So that basically the manual labor required is just for feeding the system. It's not for doing the process. So let's go through some of the lower hanging fruit that can have a direct impact on operator cycle time and task. So the first group I kind of have here on is part presenters. Part presenters can be a screw presenter, which is pictured here. And a screw presenter, what it does is it just simply spits out one screw at a time, makes it easier for an operator just to go over with a screwdriver, pick up a screw and drive it in, rather than manually going into a tub and placing it on the end of the driver and then driving. So it saves time. The second thing pictured here is a spring separator, which is basically taking a big group of springs and it isolates one spring at a time, makes it easier for the operator just to pick one at a time and not have to deal with them being tangled and fumbling around. The other one here is a label dispenser, which is basically just presenting a label to the operator where they can just grab it and don't have to worry about peeling it off the backing. It's already coming off the backing when they grab it, and then it's easy to apply. And all these things are just saving time. The final thing here is just an O-ring presenter or assembler. Basically, it's a feeder of an O-ring that opens up the O-ring, you place the part in, and it places it right onto the part. All these things have a direct impact on limiting the amount of motions that the operator has to do and prevents the fumbling around. The other thing on here is blow feed systems, which actually would feed directly to the driver itself and doesn't require any extra motion to go to it like a presenter would. And what that is that's just feeding direct to the point of where they just manually drive it down and it goes right in, and then it feeds the next one and you're ready to go with the next one.
And you can blow feed more things than just a screw, right?
Right, you can do clips, you can do screws. There's several different things that we can blow feed. It just depends on the shapes and the parts. Another thing we added to low hanging fruit is just assist tooling, which is basically what's pictured here is kind of like a ergo type arm, and that's just for positioning the tool, and it makes it easier for the operator to come down right in position to drive that screw or to place that clip. Rather than having to adjust by hand and manipulate it by hand, it's already in that position, and all they're doing is providing the downforce.
And that helps out with torque too.
Torque
right?
as well,
Because they don't have to worry about
don't have to hold it.
torque in their
Yep.
hand.
Yep. The next thing on here is we added fixed barcode readers, and what that does is that eliminates if your operator is loading parts and scanning them by hand prior to placing them in the nest. One way of limiting or eliminating time is to put a fixed barcode in the nest, which actually reads it when it's in the nest rather than having them scan it before loading it. And then when we start talking about grease and glue and adding that, with a manual, brushing it on, there's dispensing units that are available that's able to put the correct quantity, and it's something that the operator can manually run along, and it's constant. One of my favorite things on the low-hanging fruit is actually this one, the part pickup or empty nest. What this is if you have an operation that's being performed and it comes down, it performs that operation. In the motion, after that operation is complete, the part is actually picked up out of the nest mechanically so that the operator, while it's functioning, can be getting the next part prepped and be ready to place it right into the nest. They can step right into the cell and place it right in there. And then they can put their hands up, and either you can use a foot pedal or you can use a through beam laser to release the part that's in the upper to come back out, and then it can begin the next cycle. And then the other thing to mention is if the machine has a dual start button or dual opto switch where it requires the operator to hold down the dual optos for the whole process, the one thing to do would be to switch to a light curtain where all they do is they hit the opto and then they can walk away and they don't have to stand there the whole process. They can begin preparing the next parts to be loaded. So that kind of takes care of what we're calling low-hanging fruit. Then what we'd like to do is talk about mid-level automation. So mid-level automation consists of robotic assembly, which could be inserting clips, limiters, screws, welding, staking. I think the list can go on from there. But basically it's taking away functions that are just manually done, but are pretty easy to implement using some type of robot motion. The other item under mid-level is part presentation. And part presentation is helpful for the fact that in most cases you can have loading and unloading happening while another process is going on in a different station, because you're automatically manipulating the parts to bring them to each cell. And that can be done through a dial indexer, drawer slides, conveyors, or even a walking beam. There's several different ways of doing that. Another mid-level is the robotic dispensing, which kind of can help take place of the manual application of glue, grease. It even could do seals, and just kind of eliminates any issues that the manual application has as well, where you can mark up parts or put glue in the wrong spots and get it all over. Just automating that. Another mid-level suggestion for automation would be just looking at the operations that you're performing on the part and try to see if there's any opportunity to combine a couple of them or several of them into one cell. Like for instance, if you had an infrastake where you were staking bosses and it also had clips, you wouldn't need two separate stations. You could incorporate the clip driving along with the infrastake. So it's just kind of looking at that different stuff to see what could be combined. A couple other things for mid-level. The automated tool changeover. Now, this doesn't have a direct effect on necessarily cycle time, but it does have a direct effect on overall usage of your operators and them standing around waiting for changeovers. If you were to automate changeovers, obviously you have more time to start producing parts. So if you have a particular line that requires a lot of changeover, looking at fully automating it is an option. And if you look here, you can see the spinning of the two outer halves. It's basically changing over from one style to the other style. And that's what's happening in this little picture here.
And that could allow for like more flexible manufacturing too. You can make one of this one and two of that one and then one of this,
Correct. Yep. So the other thing under mid-level is just a smaller component bulk introduction. So that's kind of where you started looking at blow feeders, bowl feeders and flex feeders, drawer slides and magazine feeds. And what that is you can just kind of dump in a big bulk of them and it isolates them out to wherever you're performing the process. The final thing to mention in mid-level automation is, if it's possible and design isn't frozen, would be looking at minor design changes. And that can be a wide range of things, but a couple examples that we put on here is like converting screws to bosses that can be infrastaked. What that does is that eliminates the consumable of the screw. And if it's 4 or more screws, it doesn't improve your cycle time, because the infrastakes can all happen at once, whereas you're driving screws, they're typically one at a time. Another example is converting from adhesive to hot plate welding, which would once again eliminate a consumable, the adhesion, and then it's less risk of contamination because you're not dealing with the glue getting all over, and it's better cycle time. So the final category is high-level automation, which is basically taking a variety of your mid-level and you're incorporating automated feed system to it. So components are basically all just bulk fed. Part manipulation from process to process is fully automated, and human interaction is limited to just feeding the system and monitoring it and keeping it full of product. Now, I'm going to pass it over to Rodney, who's going to go through some examples of what that looks like.
Perfect. Thanks, Bob. Thanks for enlightening me.
Yeah.
Three
Yeah.
levels of
Yeah.
automation. I wanted to shed a little light on
Yeah.
how you could use those with Lite Brite.
Right. Yes.
Not trying to be too funny there, but
Yeah.
I guess it came off that way. So I got a little Lite Brite in my hand. Took this from my house. I use this every night to do pictures. I'm just kidding. We have obviously a lot of cases that we do this for our customers. Obviously, we didn't really want to show that confidential information, so we found a Lite Brite down at our local store, and we figured that would be a good example to be able to kind of tear apart and show you guys how it's assembled, and maybe some ways to automate it using the 3 levels that Bob just mentioned. So let's go dive right into it and dive into how it's actually assembled, and then we'll kind of go into the 3 levels that Bob mentioned and how we can actually implement those into a real life scenario and how that can help you. So here is an exploded view of the Lite Brite. Obviously, you can see the pegs on the right-hand side that the end user uses to make their picture. There's a front plate. There's a secondary cover. There's a PCB with LEDs and batteries connected to it with a switch as well connected to it. There's a switch cover that goes over that switch. There's a housing and then a battery cover. Most of these components are screwed and or glued. But we'll dive into exactly how these components get put on. And I can already tell Bob's eyes are gleaming with the amount of ways that we can use those 3 levels. So let's get into it. So first, the switch cover actually gets pressed on, and you can kind of see it. I'm not going to tear this one apart in particular because I'd be fumbling around with my hands, but we did tear one apart. And that the switch cover actually gets pressed on to the switch there, as you can see, and after it's assembled, that's what it looks like. The second step would be to screw the PCB assembly or the battery assembly into the housing, and that's pretty self-explanatory. There's 6 screws in this particular example, and that gets put into the housing. And then we have the secondary front cover, which kind of blocks the PCB from the end user to ever touching it. And that's glued on to the housing there. And as you can see, that kind of gets put inside there like that, just about. And then you have the front cover or the screw on the battery cover. You can do the front cover or battery cover. In this particular example, we did the battery cover first, but there's a lot of ways to kind of skin this cat. So the battery cover gets screwed on with just 1 screw there, making it easier for the end user to replace the batteries, right? So that one gets put on next. And then you screw on the front cover with 4 screws. And we can see how that looks there. And obviously the assembly gets packed, so the end user can install their pegs and make their pictures next to their nightstand like me. So that's what it looks like. There's a finished assembly. Obviously, you can see. Turn this on. There you go. That is what the finished assembly looks like. Pretty simple assembly, but it kind of has a lot of examples that we can use for those 3 levels of equipment or 3 levels of automation. So first, I wanted to go into let's go into the scenario of what maybe the volume is for this specific component, the cycle time, and then what you would need for like bare bones. So if you wanted to spend the least amount of money on this project, we would kind of go into, or I'll show you what the equipment you would need and the amount of operators it would probably take for that least amount of money. So let's just say, for example, these assemblies, they make 300 or are estimating 300,000 of those a year. I don't know if that's light or too much I'm sure probably not too many people buy these, but
For this example,
for this example, we'll do 300,000 because that's a pretty typical volume roughly. So 300,000 volume actually puts us at around 25 seconds part to part, which is a decent cycle time, and that's with one shift, 5 days, and including breaks as well. So first operation that we'll go into on the equipment needed is screwing or attaching your switch cover onto the PCB assembly and then putting that PCB into the housing, that full assembly into the housing with 6 screws. We would estimate you need 2 screwdrivers and 2 full-time operators on this operation to hit a 25-second cycle time. And when I say screwdriver, I'm thinking it's going to be something like maybe a DeWalt screwdriver or like maybe just a screwdriver from a screwdriver manufacturer. Obviously, it's going to be a screwdriver from a screwdriver manufacturer, but a more industrial one that's not necessarily on a torque arm. So we're thinking it'll probably take about 2 operators for that and 2 screwdrivers. So that's the bare bones equipment that you need. For putting the secondary cover onto the housing, you're going to need, a manual glue gun at the least, and then probably about 1 operator to be able to do that. And within the 25 seconds part to part cycle time. For putting the battery cover onto the housing here, it's just 1 screw. So we have half an operator. Obviously half of the time he can be doing something else. I don't think we're going to be chopping up operators, but half of this time can be allocated for some other operation. And then going into the front cover to the housing, we're screwdriving 4 screws. Obviously, you're going to need, you'd actually need 2 screwdrivers for this operation and 1.5 operator time. So maybe the screwdriver for the battery cover can be reutilized. And that half operator can be reutilized in this scenario for that second operation. So that's kind of the bare bones equipment that you're going to need, and the amount of operators that you're going to need for this assembly would be roughly 5 operators to start out to hit that volume, to hit that cycle time based on 1 shift. So going into low hanging fruit that we can automate at a minimal cost impact, as Bob was mentioning, but save a lot of cycle time and hopefully save on some operators since we all have a limited workforce, right? So there's not much to be able to be found out there. So on the first one, as Bob mentioned, well, the first operation, again, that's the PCB going into the housing as well as the switch cover. We're not going to automate the switch cover just yet. We're going to have the operator manually press that onto the switch still because it would be a little bit more cost impact to automate that. But we will be able to do some a blow-fed screwdriver and a torque arm to help out those operators for that operation. And instead of 2 operators, you're only going to need 1 operator for this operation, just because of that blow-fed system and a torque arm. So obviously that saves right there an operator. So if you on the limited task force type deal, you don't have to worry about finding another operator for this operation. And your ROI is actually, with that operator not allocating the time here, your ROI is about less than a year for this equipment. So pretty minimal cost impact, but a decent ROI here too. For manually gluing, we would expect probably about 1/4 to 1/2 operator adjustment here if we could use a dispensing unit. So this would help the operator dispense the correct amount of glue. So say the operator's putting just globs of glue on there just because they want to make sure it's sealed tight. This would make sure that the correct amount of glue is there, and also if they're putting too much on there, it would save cycle time. You're also saving, you're potentially saving on a consumable, right? So you're cutting down the amount of glue wasted, right? And then kind of taking away, you also help quality in the same aspect. The next operation, we have the battery cover onto the housing. So in this scenario, if we're going to keep, if we're going to keep it separated from the other operations, since it's only one screwdriver or one screw, and only a half an operator needs to be allocated for it, the ROI isn't crazy or justifiable for a blow fed system. So in this case, we would probably go with a screw presenter, just to help the operator get the screw onto the screw gun, and then maybe do a torque arm as well, because that's a pretty minimal cost impact. And that would be taking maybe about a quarter of an operator out of the equation as well. So your ROI would be less than 1 year again on that one. It's same thing on the glue dispensing system, less than 1 year, even though you're not saving a ton of operator time, you're saving some, and those units aren't very expensive to implement. And so you have a decent ROI on those units. For the front cover to the housing, you have 4 screws that come in from the backside, as we were saying, or as I was saying earlier. Now, the amount of screws do justify, in this case, a blow-fed system with a torque arm, and that would be an ROI of about a year as well in this case, because you're taking an operator out of the equation, a full operator, just about out of the equation there. So now with our low-hanging fruit that Bob discussed and we talked about and implemented on this example, we just saved 2.5 operators. So that's 2.5 operators that you can use on a different operation that has limited people to be able to work there. So it's really big, impactful things here that you can do, that you can implement fairly easily on current equipment too, to be able to help your operators and to be able to help your operator count.
So up to this point, are there any questions about what we've been talking about, or are you guys, is it tracking? If this makes sense, just put a thumbs up or something like that in the chat, or if you have a question, type that there and we'll try to explain further if something's not quite making sense. Got some thumbs up. Good.
All right. Guys, just couple more thumbs up. Perfect. Just let us know. Yeah, if you have any questions, pop them in that chat for sure. So going into mid-level automation, we're implementing some more costly items, but you're also saving on more operators, right? That can do something else with this limited task force again. And you're also throughout the time, you're pretty much effectively helping quality as you go through these steps of automation as well. Looks like we did have a question.
Yeah. Are there 2 types of feeders, blow feeder and bowl feeder?
Yes, those are typically 2 types of feeders systems. Your blow feed system, sometimes it's typically set up with a vibratory bowl that's enclosed, and then obviously you're using air. You're actually using air to push a screw,
Single screw, or
Yep. You're pushing a screw or a clip through a tube all the way to the screwdriver itself, and then the screwdriver will, if the screwdriver is opposite, but if the screwdriver, this is upside down, but if your screwdriver is like this, it has a little point at the end, and then it opens up for that screw to come through. So that's a blow feed system, and then a bowl feed system is that's a bowl where it goes around, vibrates, and then simulates it into a track that typically you'll have to escape off of or use a robot to pull the parts off of. So those are the 2
With blow
different.
feed, you're kind of limited too with
Yes.
what you can feed, whereas a bowl feeder has a little bigger window as far as what can be bowl fed.
Correct.
So,
Correct.
Yeah.
You're exactly correct, Bob. So if you think about blowing something through a tube, or let's say a screw, for example, and if your screw head is bigger in diameter than the overall height of the screw itself, you can think about trying to blow that through a tube. It's just going to tumble. That's what we call tumbling through the blow fed system or through the tube. and then you're not going to be able to correctly orientate that screw throughout that operation. So you would actually have to, that's what we do. Whenever a screw is going to tumble or something is going to tumble, you essentially go to a bowl feeder or a different type of feeding system, and then typically go to a pick and place operation. Or what we've done in the past is you bowl feed into a track that feeds the driver.
Yep.
Right.
Yep.
So the driver would have a track kind of connected to it that would kind of go down into it, and then you have that driver that goes up and down with the screws there if a screw is going to tumble. Good point, Bob. So going into mid-level automation, to Bob's point, a little bit more cost, saving more operators, and typically a little bit more quality assurance here. Going into our example, the Lite Brite, the first operation, you have the switch cover that you're going to be pressing on with an operator. That's a pretty easy operation for an operator to do. It's not a really snug fit. You don't need to press it on very well. So what we would recommend is you continue to use that operator because you're not going to get a great ROI with bowl feeding that component and pressing it on. So we'll continue to manually put that on. That's typically quick and easy. And then what we would recommend for mid-level automation would be to turn those screws into stakes. So we would use Emperor stake or nano stake to stake bosses to secure that PCB assembly inside the housing instead of screws. And that has a couple advantages that I believe Bob pointed out earlier is you eliminate the consumable, so you're saving money on screws. And then you also save on cycle time because all those Emperor stake or nano stake modules, depending on what is used, all those can fire at one time. So you're saving on cycle time and you are eliminating consumable. And when the machine is in operation, the operator can leave the machine, if you have a light grid, can leave the machine and do something else, maybe load another machine, do something else. So in this scenario, you actually go from the initial 2 operators all the way down to 1.5 just by taking those and turning them into staking points. And what that does for you is since Emperor stake the Emperor stake and nano stake are pretty cheap, are really cost effective, and you can do them all in one time in a press, a simple press. Your ROI for that is actually half a year. So it really saves on, you get a really good return on investment, and it saves on a lot of operators. So it's a huge thing that you definitely want to do if you could, right? So that's one way that we would mid-level automate that one to save on your task force. And then going into the next one, you're gluing the secondary cover into the housing. And as Bob had mentioned, with gluing, you typically have a lot of room for air, and you have a consumable, and we want to typically change that into a welding scenario, so you don't have to worry about a consumable. And typically gluing needs a lot of let out time or a lot of curing time, whereas welding, it's much less. So it kind of helps out all the way around. What this would do is it would take your one operator and turn it into half an operator. Your machine is a little bit more in-depth, a little bit more expensive. So your ROI is about 1.25 to maybe 1.5 years. So your return on investment takes a little bit longer, but your assurance and quality is pretty solid, and you're eliminating that consumable as well. So a lot of plus sides to that, and you're typically saving on cycle time. So I think your operator is going to have an operator, and what that leaves us is the Emperor stake or the staking operator can go to the hot plate welder and place the parts that were just coming out of the staking mess into the hot plate welder. And we could also speaking of a low hanging fruit that Bob likes,
Yeah.
we can also do part pickup on both those operations to make it even go quicker. On the last operation, what we would recommend is, which maybe a lot of you guys have already thought of, is combining the two operations between, of the battery cover, screwing on the battery cover and screwing on the front cover. And what that effectively does, and then also robotically installing it, what that effectively does is take 1.5 operators and turn it into half an operator, operator's time, because all they have to do is load up a nest and have a robot install all the screws. So that really saves on cycle time. Your ROI, again, a little bit more expensive piece of equipment. ROI is less than 2 years. So still not bad for return on investment. But you're getting up into more expensive pieces of equipment, which absolutely helping quality, as we mentioned, and with a limited workforce. So those are some ways that we would mid-level automate this example, this Lite Brite example. And overall, we went from 5 operators from the beginning, and now after mid-level, we just went down to 1.5 operators. So you're saving 4 or 3.5 operators there just from doing that. Now, going into high-level automation. So this is what we like to call lights out automation. This is pretty much all the operations are automated. Your operator is only feeding the systems, okay? So they're feeding the bowl feeders, they're feeding, if you have blow feed systems, they're feeding the blow fed systems, they're feeding, trays, whatever is feeding into the automation or whatever small components need to be fed in, they're feeding the equipment that isolates them or simulates it for the automation. So obviously we're taking all the whole assembly on that left-hand side, we're taking that, putting it all together into one big automation cell. You can do it kind of a lot of different ways, as Bob said, conveyor, dial indexer, walking beams. There's a lot of ways to move a part from operation to operation. In this case, we just, for simplicity's sake, we chose a dial to show you how you could potentially automate this solution and actually bring it down to half an operator. And what this would do, this fully automated system, for a one-up system, it would be roughly less than 3 years for a return on investment. But again, you're saving on all those operators. You only have to have half an operator to tend the system, and you're also gaining on quality assurance as well. Two big things, especially this time in this day, in this climate. The advantage to an automated system like this too, or one advantage, I guess, a 2-up system or 2-up nesting or 3-up or 4-up, however many you want to do, it's pretty easily implemented. So there's not much extra cost that you're going to incur going to a 2-up, and that's going to double your volume. So if you have really high volumes, this would be a route to go as well, on top of saving operators, right? Because you're just not able to effectively do millions of parts with manual operations.
Another thing to consider with high-level automation is, we didn't show it here, but you can, like, some of these parts could come off the injection molding machine directly into the cell, which means you're eliminating the operator who would have been running the injection molding machine. And you're saving that labor as well. So that's where high-level automation, you can do a lot of different things to eliminate even additional labor that really wasn't a part of the original scope.
And
Absolutely.
we've built cells that the injection molding machine feeds the automation cell, and then there's automated guided vehicles taking packed parts out to the trucks. Like, no one touches it the whole time.
Yep.
So.
Lights out to me.
Yeah.
Yeah, so that's exactly right. It's minimizing the labor, and any way you can do that, especially, going for the injection mold machine. We see quite frequently, to eliminate these operators. So good points, guys. Thanks. In this example, like Bob said, we did not include it on this. Some of these components could come from injection mold, and what we've seen too is injection mold parts. If you're smaller components and you want to have a conveyor go right into a bowl feeder that goes into our system, we can do that as well. There's a lot of things you can do that really help with the operator count. So, but on this example, we're going to say on the bottom side of this dial, you're actually robotically loading a lot of these components. You're doing the PCB assembly, which, maybe you do by trays, and that's what's shown in the middle on the bottom. And then on both sides, straddling the trays, you would bowl feed maybe the housing and bowl feed maybe the switch cover. And then you would robotically place it in the nest. You would add the switch cover to the PCB, and then that robot would probably put the PCB into the housing for the next operation. That would do the infra staking or the nano staking of the PCB assembly to the housing there. And that would just simply have a press for those nano stake modules, and they would all be done at once. And then you would go into the next station where you would have, say, maybe a hot plate welder or a rapid conductor that a robot picks the parts up off of the dial, places it in the housing subassembly, I guess that would be the part, places it into the lower nest, and then takes the secondary cover and places that into the upper nest. And then you do your hot plate welding, and as the hot plate welder is going, you have the robot place the front cover onto the dial for the next operation. And the next operation, you place the front cover, and then you place the finished hot plate weld assembly over the front cover for that next operation to screw from the back side. And that's essentially what that last station does. You have a robot blow feeding screws to the end of arm, and screwing on the battery cover and screwing on the front cover. And obviously we would have to have a bowl feeder to introduce the battery cover into the dial system. And then that robot could simply place that into a packaging system, to Jason's point, AGVs, into a bulk container, into a separated bulk container. Pretty much the sky's endless on packaging type deal. So that would be a way to fully automate this, and only have the operator tending the feeding and outgoing. So you would have, in this scenario, you would have the operator feeding the bowl feeders. There's 3 bowl feeders there, 1 tray feeder for the PCB assemblies, and then on the top, we're showing a couple, top right-hand corner of that concept, we're showing a couple vibratory table feeders that would typically have a camera to guide the robot for pick and place. So a lot of ways to feed, and those would be the only things that the operator actually tends in this system. And so obviously that won't take up the full time of the operator, so you would have half an operator, so they could kind of tend something else during that operation. And I think that pretty much wraps it up. We wanted to thank you guys, and I also want to extend the invite. We typically do go out and visit customers to help out with implementing these 3 levels of automation, and essentially just help on figuring out what you need to do to automate, and RFQs. We help out with RFQs too. So it looks like we did have a couple questions come in, Jason.
Yep. So Marty asked, can you touch on our project management process for mid and high level applications?
Okay. Like project management.
Like how does our team manage those types of projects?
Xstall's team?
Yeah.
Yeah, absolutely. So we have a full automation group in our operations team that's comprised of several, I don't know exactly how many controls engineers, probably 5 to 10, but several controls engineers, several builders, several designers, and several manufacturers, so material conversion for all the components. So we vertically integrate with MC or with manufacturing all of those components. We have a team that specializes in that every single day. And then there's also a dedicated project manager that heads that team for your specific project. And it's the main line or direct line of communication from your team to our team. Typically how a process goes is once you guys order automation or a custom cell, we would process the order. We would internally look at the scope of work, make sure the project manager is up to date on that. He feeds that information to his team, and then we internally kick it off and have a customer kick off with you guys to start things off to make sure the concept is what you guys would like. And then we have several design reviews, sometimes only one design review, depending on the project, but potentially several design reviews to make sure we're all in line and all good to go. We release design to manufacturing. Our guys back in manufacturing produce all the components and then bring them back to assembly. And then assembly puts everything together and controls debugs and makes sure it's running great for you. The project manager is throughout the whole process your direct contact.
Another question in here is from Camille. I hope I'm pronouncing that correctly. He's saying that they have InfraStake and they use a high level automation equipment, and they don't use operators but AGVs that feed the production, and they're curious about like remote control systems. So like basically you'd be able to stand in front of the machine and program it and set up your process parameters. But then the way I read this, he's interested in the ability to like sign in to that controller remotely somewhere else and then manage the process, maybe from different plants in different countries and stuff like that. Like, is that something that he's asking about InfraStake specifically? And Camille, we can follow up with you afterwards, but generally for the whole audience, like what kind of options are available for that?
Typically we can do remote access and we can implement on that machine. I don't know if I guess that answers your question totally, Neil, but we can implement remote access and be able to have, I guess, Xstall help you if say there's a troubleshooting thing or your team access the machine at many different plants.
Yeah.
So I believe that would be what you're looking for. We can absolutely implement that on all of our systems.
Any other questions? Keep putting them in here. While you're doing that, I'm actually going to put in a link in the chat. If you're interested in attending our laser welding webinar next week, we're going to go through the basics of laser welding, and we've done this one before. Maybe you've been on it or not, but it's really good for people that are interested in learning a little bit. Just, is laser plastic welding something that you can use? Maybe not. We'll talk about that in this webinar, and you'll get to learn a little bit more about that process and how it works, what the benefits are, what you need in order to be able to use it. And that'll be at 11 a.m. next Thursday. So that link is there so you can sign up. And as Rodney mentioned, these guys, they travel and they are more than willing to come into your facility, talk with you, see your current process, see how you like your manufacturing equipment built. Everybody is different. Everybody likes different things. And then they can lean in and help you with maybe ways to improve your process, or maybe you have a new application and you want to talk through that. We're happy to do that. We can do that virtually as well, so we'll be following up with you after the webinar tomorrow with a recording of this, and then you can just reply to that with saying, hey, I would like you guys to help me with my application. So any other questions? Otherwise we can wrap this bad boy up. We'll give a minute for people to type. I think it was pretty good.
Little picture.
Yeah, yeah. Rodney's gonna draw something on his little tiny Lite Brite. If you think of a question afterwards, feel free to send us an email and let us know, and we'd be happy to take care of you. But with that, I think we're gonna sign off. So thank you all for joining, and have a great rest of your day.
Thank you guys.
Guys.
Have a great day.